Well, I mean, that's why they tell you to use hot water instead of cold water. It's better. But, like, no, literally, like, fire. Like, germs can't survive at a certain temperature.
Cold water's better for your fire.
It is better for your skin, actually. Mickey?
Actually, you can use both. They'll both work the exact same.
As long as you use soap.
Yes.
Yes.
But bacteria also die from any extreme change in temperature.
Yeah, and also you freeze it. I think certain parts of it can continue to exist. But especially if you approach, like, absolute zero. Like, absolute zero is negative 273 degrees.
What's the title of our notes again?
We're doing more more solving problems. So we can call today, I guess if you really want a title, we can call it 5D or not 5D.
That is the question.
Who are you? No. Who can remind us what the 5D is?
Oh, I can.
Bella?
Define the side.
What?
Yeah, define the side 3.
Okay, well, that's what the D's are, but what is the 5D process?
Okay, the way you do is take trials to figure out to try to figure out a certain algebraic equation.
Yeah, so we take trials, right? It's, what did we call it? Like, if you only wrote down a couple words yesterday, Lily?
I wrote a guess check modifying process to make any answer less scary.
Yeah, it's a guess check method that we use to kind of like reason through, and we use expressions with it, right? So if we scroll down here and we look at the example that's on the top of your green paper, and then we're going to put your green papers away. The 5Ds, as Bella reminded us, describe, draw, define, do, decide, declare. So if they gave you a problem like this, where they said the base of the rectangle is 13 centimeters longer than the height, we could then call the base h plus 13. And then the other thing we have is the h, right? So if we define variables, we could say h and h plus 13. We then try these things out. We decide is what we got too high, too low, and we modify. Now, as we talked about yesterday, though, we don't have to use the 5D process, right? We might use an algebraic process. So today, as we work through these problems, the questions that you want to center yourself on are right here. So anyone want to read for us? So we don't all have to read, like just one person can read. Bella, go ahead and read those questions for us.
All right. How can you describe this problem? How can you decide how to label the column? How can you organize the column? How can you decide which quantity to start with? Does it matter which one you choose? How can you decide which number to try first?
This question. Thank you very much, by the way. This question right here, does it matter which quantity we choose for like the trial? Anyone remember what we said yesterday? Like the thing we want in the leftmost column? If we go back to the thing we were just looking at, would we want the h plus 13 in the first column? Would we want the modified variable here? No, you want just the variable. So that question of does it matter what we start with? Yeah, you want to start with just a variable and then modified variables. So, anyone know what a scalene triangle is? On your paper, write this down real quick. Just somewhere.
I know.
Draw this exactly like that. S-I-E. Araya, do you know what I'm getting at?
No, but I know the scalene triangle.
What's a scalene triangle?
Isn't it a triangle that has no sides?
Yeah.
Good job, Araya.
A scalene triangle has no matching sides. An isosceles triangle has 2 matching sides, and an equilateral has 3. So scalene triangles are like the messy ones. There's nothing special about them. They just all 3 sides are different lengths. Go. So now they tell us the medium length side is 7 longer than the short. So on your graph paper, we don't need your green paper anymore. You can put it under your graph paper. You can put it in your binder. You can light it on fire if you want to sanitize it.
You have a lighter?
Please don't do that because then you won't be able to turn it in. Now your Pompeii journals, those we will tell you can light on fire.
Cool.
With or teacher, I've done it for kids before. All right, on your graph paper, I need you to take 30 seconds and just try to write down expressions, not sentences. You're not writing words. Expressions or equations to represent what we've highlighted. Now, the first thing we could say is there's a short side, a medium side, and a long side, and we could go from there if you want. Short, medium, and long. Take at least 30 seconds. Don't talk, just write. How do we write what we are told? If you can't read, you're going to want to scooch forward. Middle school is when I realized I needed glasses. But yeah, this is not on your handout. We just have to write these things down. You could at a minimum put S equals M equals L equals. And because you've all been waiting in great anticipation since about 23 hours ago, random cards, don't you worry. Rest in peace, what? Oh, yeah. That wasn't really poignant right now, but yes. Callie, what do we know about, well, actually, you can choose since you're first. Do you want to tell me something about the short side, medium side, or long side? Sure. Bella? Tell me about one of the sides.
Alright,
Tell me M equals, S equals, or L equals.
M equals 7 plus S.
According to this, M equals longer than the shortest side, so M is S plus 7. Remember, longer than is going to add to something. We got to figure out what that something is. Lose. Give me either the S or the L. Look at what's highlighting green. What does this word tell us to do? Yeah, do what with times 2, right? So, twice what? Twice the short side, right? So, long is 2 times S. Guys, notice we're working with S. We're working with S. So, S is just S. We're working with S. And then they tell us short plus medium plus long equals 39. But, Savannah, what can I do with this equation and these equations to clean things up?
I'm not sure.
So everyone take a pause. Make sure you have what I wrote up here written on your paper. Right? Because this won't make sense unless you have this information. I'm not asking you to write this. I'm just asking you to write the expression so it makes sense. Morgan, what can we do? We could do the 5D problem by setting up everything we know in those columns, right? We have 3 columns of things. We're talking about 3 things, right? 3 sides. This is our decide, right? Or our do, really. We're trying to make 39. So, I'll go ahead and use white just for fun. If we set up our trials, we have S, M, and L, which really M was S plus 7, and L was 2S. So I'm going to create columns for those. You can use the template from yesterday, or you can just get used to just throwing this on some graph paper. We got 3 columns to test. Then what we're checking is, does S plus M plus L equal 39? And this is our decide. The other D is our declare, which is just our answer, right? When we're done, we can declare. So, Nikki, give me a guess. Give me a guess for the short side.
Short side.
Ooh, hold on. Lily complained. This is only 4. The D we're missing. That would actually be wrong. The 2S. Well, actually, it depends. But you don't have to draw this. But if you want to draw a picture, we could do short side plus 7, and 2 times the short side. Now, I don't really know which of these would be which, but short side is going to look short. Problem is, my picture isn't accurate. So here, I can't really trust the picture very much. But Nikki, you want to give me a guess? I mean, can I guess 50? No, it's way too big, like, obviously. What about, like, 10, 15, 5? I mean, just try something. 7! 7's a great number. It's prime, it's fun, it's lucky, apparently. What does that make the medium side? 14. What's that make the... Oh, 14 also. What's 14 plus 14 plus 7? 35. Ooh. A little too low, right? Our guess is too low. So, Zach, what do we do?
So we hire it to like 8 or 9.
What are you going to pay it? If you're going to hire it, you have to...
So, yeah, probably what?
I was trying to make a bad joke. You said we hire it, and I asked you what you're going to pay it.
Yeah, so probably 8.
Probably 8? All right. Now, Zach avoided the trap door that actually my afternoon class, or no, maybe somebody in this class pointed it out also. Like when you point out the trap and you're like, guys, this is a trap.
It's a trap.
If we bump this up by 1, it bumps that up by 1, it bumps this up by 1, and it actually bumps this up by 2. So realize this doesn't add 1 over here, it adds more than 1. So then we do the math again. 16. I have some people that I don't think are with me. What does this equal? 39. Now everyone draw a squiggly beneath this. Because there's another way we can do this. But wait, there's more. I have not yet. That's why I'm walking over here. Bella, do you know the other way?
I don't know if I do or not. I combined M and L to like a smaller equation. What better? It was S times 3 plus 7, which would be medium and
No, wait. Is that all 3?
that would be medium and long together. And then,
Could we put all 3 together?
yeah, we probably could.
So guys, stick with me for a second. Put your pencils down for a moment. If we come back up here, the problem has told us the 3 sides add up to 39. Right? We good? No issues with we add up to 39. Then the problem told us long side is twice s and the medium side is s plus 7 and the short side, well, how do that? It's s. So we have what Bella's essentially getting at. Bella added up these and said we have 3s plus 7, right? Put the medium and the long together. But if I want to add up all 3, grab this s also, how many s's do we really have? 4. So what I want you to write out, hold on, because I don't want you to just jump to writing that out. We're going to replace these values with these expressions. I got some people in the half with me, so let me tell you, this is the faster way to the right answer. This is the faster way to the right answer. So if we replace s, well, s just gets replaced with s. M gets replaced with s plus 7. Please write this down. And L gets replaced with 2s. Questions on what I just did? I substituted the medium expression for the M, and I substituted the long expression for the F. Toby, you with me?
I am.
Okay.
I just wanted to say, you have to be careful when you use S with numbers because it can look like a
Yeah. Yep. Yeah. Nothing I can do to fix that. So, Sarah, you with me? So we have S, we have another S, and we have two more S's. How many S's? 4S plus 7, right? 4S plus 7 equals 39. Are we okay on how we got to here?
Oh, yes. Yeah.
Our short side was S, our medium side was S plus 7, and our long side was 2S. What?
Is this a long lesson?
I mean, we're just going to do this over and over and over again. Not the same problem, but until you're like mastered. I mean, once we're mastered, then we can just work on homework or something.
Are you sure about that? Are you sure?
Yes.
We're mastered.
Now, everyone should have this written down.
Can we prove our mastery to you? See if we can work on homework?
I could move quicker if people stop asking off-topic questions. You know I'm going to make you solve at least 2 more of these before I let you do your homework. We could now subtract 7 from both sides. Please write the -7 under those values to see we did it to both sides. I'm Nick.
Whoa. That was so random.
I'm just trying to make sure people take the time to do what I'm asking them to do, and I'm trying to let them catch up.
Yeah, because we're very much.
Sorry, I should have gone and stole Mirabelle's sticker because Nick looks like a little disaster right now.
Yeah.
Dude, you gotta clean out your binder.
Yeah.
I say that with love, but you gotta clean out your binder. That's too many papers. We have 4 times S, so we're wondering what number times 4 equals 32. If we don't know that offhand, divide by 4 to get there. And S equals 8. So then M equals 15, and L equals 16, like we just found. Now, to those of you saying, wait, I thought it was 39. It was,
Together.
until we subtracted the 7 from the medium side. Remember here, we're trying to get rid of the extra, the extra number that we don't want. That's why we subtracted the 7, but we had to do it over here also. So guys, here's the point of what I'm doing. I'm only going to do one more 5D process. Then I'm going to ask that we all start trying to think algebraically, because the 5D process is just the beginning steps of algebra. If I'm being honest with you, the 5D process is a tiny bit silly because it wastes your time. We can work more efficiently if we just do the algebra. Really, those are the same results as what we had from the 5D process. Because it's the same problem, right? We just solved it in a different way. So I want you to try this next one on your own. First, like we just did, writing down what's important. Then you can either set up a 5D or try to do the algebraic method. I don't care which way you take. I'm going to show both on this one. Then the next one, I'm only going to do the algebraic process. So I'm going to highlight the stuff that I feel like is important.
Can we do both?
Yeah, you can do both methods. That'd be great, actually. The difference of my numbers is 4.
Isn't product multiple?
Yes, product is multiplied. I mean, A and B, X and Y, doesn't matter what you call your two numbers. What does it mean if the difference is 4?
Subtract them together.
Yeah. So either we could say one of them is the other minus 4, or one of them is the other plus 4. Right? So if we say X is X, we could say Y, we could either say X minus 4 or X plus 4. I'm going to say plus 4 because positives are easier to work with. So that means the difference between x and y is 4 because y is 4 more than x is. So the difference between them is 4. The other thing they tell us, product, I guess I should have written this in blue. The product of x and y is 96. But remember, we know what y actually is. It's 4 more than x. So if you 5D process this, and I'm going to write out a really small 5D process over here, dive in, try to solve this on your own. Do not wait for me. Oh, yeah.
We should probably divide this by 2.
We're allowed to take away the 4 or whatever. So if we just take away the 4, we would be at 92. So then,
Let's divide it by 2.
yeah, we divide it by 2.
So then add 4 to that.
Wait, wouldn't it be? So, oh yeah, when you just subtract 1, so then you get 82. Wait, you would divide by 2, right?
Okay, I'm gonna divide by 2. 46. Or 46
We have two numbers that multiply to make 96.
It has to be like around
Sarah? 8 and 12, Sarah says. So is 12 4 more than 8? Yeah, we make that work. Then we check or test. Now, Sarah, did you already know 8 times 12 makes 96? So that was kind of cheating. Not cheating. She just knew, right? She's like, I want to think of what numbers multiply to make 96. Well, there's not a lot that I know of. 8 and 12 work. Now, if we had guessed something smaller or guessed something bigger, we would have then modified our guess from there. Like, I normally start guesses with 10, unless 10 seems like it doesn't work. Like, obviously, starting with 10 is just nice. It's normally good. So if I had started this and I had done 10 and 14, I would have then found out that that was 140, and I would have been too high, and I would have shifted my guess down, and probably down to 8.
Would you like it?
High. Really fast, though.
Yeah.
Questions? Now, I heard a couple of you solving this algebraically and really just doing it in your head. I heard you saying, well, if we have two numbers and one is 4 more than the other, take 4 away from the end. No, I didn't want to clear all of the ink. I still want to keep my highlighting. If we write this out algebraically, what we're saying is x times x plus 4 equals 96. Sorry, it's probably that. No, it's not. It's a 740 number. Now, here's the problem, though. X times x plus 4. This multiplication goes to both of these. And that becomes x squared plus 4x. We don't know how to deal with that right now. This situation, a lot of people not paying attention, is actually called a quadratic function. And you should pretty much be afraid of that word because it sounds scary and you don't know what it is. Now what that actually means is this function, if we put it on a graph, it makes a U. Or, and here's the cool thing about quadratics model gravity. So if I go up on top of a set of bleachers and I throw a basketball off the top, it will fly in a parabola. Its behavior is quadratic. But we don't know how to deal with this, right, Molly? Yeah. So since we don't know how to deal with that, don't. This is one problem where the algebra, we can't do it yet. So I heard some people trying to subtract 4 and then trying to divide by 2. Like, that won't actually work here. Now, if instead of product, they had given us sum, then it would work. If we had the sum was 96, but that's not what we have. We have product, and that we don't know what to do. Does that make sense? That we shouldn't take that way because we don't know it yet. You aren't expected to know that till sophomore year of high school. Bella?
Oh, yeah. Technically, you're just saying to do the 5D process without the
Do the 5D. Or like Sarah did, just kind of think through it. Like think through numbers like 6 and 10. Well, that's not big enough. 7 and 11. Well, that's 77. 8 and 12. Like the 5D process is also designed to help you learn how to think through these problems, right? So if you know the difference between the numbers is 4, you can start with 1 and 5, 2 and 6, 3 and 7, 4 and 8. Like you can just start thinking through the numbers that have a difference of 4. Try this one. I want to not say anything for 5 minutes and see if you can solve it. I will highlight, but.
Why didn't they count how many baskets? That seems kind of silly.
Guys, you're acting like middle schoolers again. You want to solve the problem, not ask why didn't they count the baskets.
You're not allowed to ask the taxes in school.
Can we make an agreement right now? Can we call Jenny Y and Joan J? Because we have 2 J names here, and that's annoying. Can we call Jenny Y just because she has a Y in her name? And let's call Joan J. Let's just make that agreement right now so that we can all kind of talk in the same language. All right?
Why can't it be J-E and J-O?
You don't want to use 2 letters because later in math and science, multiple letters mean different stuff.
Oh, okay.
So yeah, we want to use a single letter for it. Thank you for asking. Seriously, thank you for asking. But guys, like that was a great question from Rhea. Why can't we just abbreviate their names? We use 1 letter for variables in math. We don't use 2 because that means something different.
What does it mean?
Well, like in science, like JE or HE or those sort of like those are elements, right? Now there are single letter elements. I get that, but like when we're talking in math and variables, we just use 1. It's just kind of that like agreed upon thing.
Oh,
Tammy.
I like how the letters like myths.
I really didn't count how many baskets.
Look, it's hard to count baskets.
I thought they had an analytics guy.
No, their statistician quit.
Oh.
What? He quit mid-game.
What happened? He quit.
I'm trying not to talk and give you guys time. I'll even offer up. Oh, no, I don't have my camera. Sorry, I was going to say I'll put your solution under the camera, but I let Mrs. I let Mrs. Goldring use it.
Times 2.
So those A is G. Yeah, Alexis. What's her number? The green. Would be G plus 6. And she made the same number. Oh wait, John made 4. So G minus 4.
All right, Jenny, Grace, Alexis, Tammy, Joan.
T equals J. Yeah, there's 5 of them. And then 5 other people made 40 baskets.
Anybody have questions?
So
No, all together they made 40.
And then all this.
We should try to find G. No, we should find G.
Don't use it like lotion. It will dry you out real bad. And then you're gonna look like an old man with like cracked open. I have not talked about Dr. Smith in here, I apologize to him. Dr. Smith was my favorite professor at Otterbein because when we would approach problems that looked like they were like impossible to solve, he was so good at encouraging us to just do anything, right? And quite genuinely, sometimes in college the problem can't be solved, and they end up telling you like, yeah, this is one of those famous problems no one's been able to solve yet. You're like, we just spent an hour on that. No, but this problem can be solved, right? So do something, anything. Jenny, remember, she made 3 times as many baskets as Grace. Okay, so what should I write for y equals? There.
Y times 3. Or G times 3.
G times 3, which we're going to put the 3 first and say 3G. So there's one of my variables. Y equals 3G. Alexis knows that she can make 6 more baskets than Grace. Okay, so Alexis, what do we put for her, Savannah?
6 plus G.
Yeah, and I'm going to put the G first now, actually.
See, you are cheating your mind.
If it's multiplication, we normally put the number first. If it's addition, we normally put it second. Wait, if Jenny is talking about Grace and Alexis is talking about Grace, what should we put for G? Just G, right? Let's just talk about Grace. And Grace is like, why is everyone talking about me?
Because you're so hidden.
Now, Joan thinks she made 4 fewer baskets than Grace. What do I write, Eric?
G minus 4.
Yeah, for J, right? Now, do I put T equals J since they told me Tammy's the same as Joan?
That's what I did.
That's silly. This is in G, that's in G, that's in G, that's in G.
G minus 4.
Can I put this in G? We should. So, yeah, this is true. Tammy equals Joan. But what's better is to say she is G minus 4.
Why we need teachers to tell us these things.
Altogether now, they made 40.
Should we copy that weird squiggly?
It's like a mustache.
That's a weird.
Sure, I'm just restricted by my screen. You could have written all of this vertically. You know what I mean? You could have T and J down below A. Now, like I said, I'm not doing 5D process here. We don't actually need to. If we did 5D process, imagine this, guys. We'd have a column for Y, a column for G, a column for A, a column for T, a column for J, another column that we'd have to add them up in, and I don't know about you, but it's not even 10 o'clock yet. I vote no.
Yeah.
So instead, this total is just all of them added up. So let's instead just write them all out added up. So 3G plus G plus, you should write this down with me. We're doing algebra now. Plus G plus 6. Right, I'm just grabbing each piece. Then G minus 4. Plus G minus 4. Guys, this is why we've been doing the like term work we've been doing. Can I put G's and numbers together? Like, can I put G minus 4 together? Like, can I take 4 away from G?
We can't do it yet.
We can't do it yet, right? We don't know what G is. Get all of your G's together. 3, 4, 5, 6, 7. Right, so we have 7G when we put them all together. Then 6, negative 4, negative, so negative 8 and 6, what would that be? Negative 2 or minus 2 equals what? 40.
That's a good color of paper.
Correct.
Yeah, I like
My highlighter doesn't really write the way that I want
Looks
to
like
write
watermelon
letters.
colors. Those are watermelon colors.
Oh, yeah.
Wait a minute.
All right, now stop. Pencils down. Who is confused at how we got here? Olivia. Because we have positive 6. That's a great question. Thank you, by the way. Hey, chill out. We have positive 6 right here coming from the Grace plus 6. But then we had Grace take away 4 and Grace take away 4. So really we had to take away 8 points and we only got to add 6. So really at the end of it all, we have to take away 2 points from the 7 times Grace's points. So essentially this must be 42. Because when we take it away, it equals 40. Does that make sense?
Oh.
Eric?
Wait, wouldn't that mean it would G equals 6?
Well, hang on. You're ahead of us. So if we have this, we can then add 2 to cancel out the minus 2. And what that means is 7G must equal 42. And Eric, when we divide by 7, we get that G is, you can say it now.
6.
Grace is 6. Any questions how we got there? 40 points, I don't know. Now hold up, we're not done. Now that we know Grace is 6, go back up here. Okay, so Grace got 6 points. How many points did Jenny get? 18. How many points did Alexis get? 12. Oh yeah, 12. How many points did Tammy get? Oh, sorry, Tammy and Joan. So now we know what each of them scored. Questions. Here's what's up. Tomorrow. Hey, give me your focus while you're putting stuff away. You can start putting stuff away, but I need you to listen. Tomorrow, we're going to be doing more of the same, but we're going to be making posters. So you're going to be in groups, and you're going to be making posters. So if you're going to then say, oh, wait, can I go to my locker to get Molly? This is who I'm thinking of. If you're going to want to go get art things, because I'm going to tell you tomorrow, hey, we're making posters, bring those to class. Okay? Bring your stuff to class. Yes, we're like if you go down the hallway that way, it's Math 8 already made posters this year.
Why? Why would you make that?
Why do you have a negative attitude?
Yeah, I'm married in.
What do you put on the map?
The solution.
Map.
All right, have a great day, guys.
Can you give an example of the impossible?
Of the impossible.
Like the impossible, like,
Impossible. Oh, Google it. There are like just Google unsolved math problems. There's famous math problems that have just never been solved.
if I solved it, you think I'd get like $1 million?
Yes, there are prizes for these unsolved math problems. That's not even a joke.